Thank you. I'm glad that even if I forget, somebody in the class will remember. Okay, so this is very important to practice. Again, I know that some of you maybe aren't worrying about this right now, but this is super critical sort of thing that you will be doing in the future. Okay, so we're coming up on 5 minutes and 63% of you have answered. So I'm going to give you another 30 seconds or so. And then we will take this up. Hamza, I would read the test instructions. It'll tell you exactly what's covered. Okay. This is pretty good numbers. I'm happy with that. So the majority of the class said A, and then followed that with C. One person said D. Okay. The answer is not A. So despite the fact that the majority of you have chosen A to be the correct answer, A is absolutely not the correct answer. So this is an important point because this is a common mistake that students make when we do these sorts of problems, is that they actually basically get the orders of things wrong. So this is a really great learning point for us to understand now. And the reality is that when you set up these sorts of problems, what you want to do is don't guess, don't sort of meta where you think the 1 should go and the 3 should go, and whatever the case should be. It's not B either, no. So if it's not A and it's not B, it's probably not D. Yeah, it's C. Yeah, exactly. It was A or C. And so the question was like, was it A or was it C? And we need to see, like, this is very important because if you get this wrong, if you thought it was A and then I asked you to solve it, you'd have gotten a completely different answer than if you thought it was C and you tried to solve it, okay? Now, moving forward, this is 100% what a term test question will look like, right? Obviously for term test 2, but this is what a term test question will look like. You will be responsible for setting up, excuse me, the linear system and then solving it. And if you get it, if you get the wrong system, you're going to be in trouble, right? So here's how we're going to set this up. So this is question 9. And what do we want to do is let's break down, even just kind of sometimes, especially when the problem's quite wordy, you need to go into it, you need to try and extract the relevant information. And I'm warning you right now, we actually could include information that's in no way relevant, so-called red herrings. And it's up to you to recognize what information is relevant and what information isn't, because that's going to happen in real life as well, right? You might be given too much information, and some of that information is actually not relevant to the solution, and you have to identify what's appropriate and what is not. Okay, so I kind of like make this a little bit more bullet point when I do it. So I'm going to say bundle A. Right, I'm just going to extract the relevant stuff. What do we got? We got 1 red, 3 blue. And I'm just going to be a little bit boring and just kind of use RMB. Okay, bundle B is what? 1 blue, 1 yellow. And again, I'm even going to write it kind of staggered out like this so that I can really easily see how much of each thing I have. Bundle C is 2 red, 1 yellow. Like this, okay? So yeah, so what I'm going to do is I'm going to say, all right, let's let a vector indicate how much of each potion occurs in each bundle, right? So let's set, or let's, how do I want to say this? Let the vector, why is my pen dying? This is driving me nuts. It's been dying all day. I changed the battery. It's still giving me trouble. Very irritated. Okay, so let's let the vector RBY denote the number of potions in each bundle. Okay, so bundle A will look like 130, right? Bundle B, and again, if you see the pattern here, don't even wait for me, just keep going, right? Bundle B is 011, and C is 201, like that, okay? Now, if I let X be the number of bundle A I buy, Y be the number of bundle B, and C be the number of bundle C, so let X, Y, and Z be the number of bundles A, B, and C that we buy respectively. Then the total number of each potion that we buy is X times A plus Y times B plus Z times C. Okay, so let's make sure everyone agrees with that fact. All right, I'll take a little break here, give you a chance if you're writing to catch up. All right. But maybe let me annotate this. So this is the number of A that we buy. And this is the number of potions in A. So do we agree that X times A is the number of potions that we bought in total from A, from bundle A, right? That vector is acting sort of like a basket. And then X is telling me how many of those baskets I actually purchased, right? So if I had 3 times A, that's saying like I bought 3 bundles of A, and it's keeping track of how many of each potion that I've bought, right? So direct messenger, the last part has me confused. Elaborate, like which part exactly has you confused? Just let me know. So it's just putting a multiplier on the vector, exactly. Yeah, what is X and A? Okay, so A is this vector, right? It's bundle A, and it says we have 1 red potion, 3 blue potions, and 0 yellow potions, right? So this is the bundle A, right? It has 1 red, 3 blue, 0 yellow, and then X is the number of bundles of A, right? Okay. What's in yellow number A by? I'm not, oh yeah, just A by, yeah. The number of A that we buy. I just kind of running out of space, so I was being a little sloppy there. Okay, so I buy X bundles of A, I buy Y bundles of B, and I buy Z bundles of C. If I add them all together, that's the total number of bundles that I have, right? Does that make sense? Do we need the number of A to equal the equation, if that makes sense? Not yet. So here, let's simplify this now. Because we don't know what it has to be equal to yet. It's not yet an equation. So let's put everything in. 1, 3, 0 plus Y 0, 1, 1 plus Z 2, 0, 1, like that. And if we combine them, we get that. Okay, so this now as a single vector tells me the total number of potions that we've bought. Okay, does that make sense? And yellow, exactly. Yellow is the 3rd row, blue is the 2nd row, and red is the top row, right? That's actually great. Let me kind of include that just beside here, right? Here's red, here's blue, and there's yellow. Okay, now we need this to be equal to, because the problem actually tells us that we need, what does it say? 6 red, 7 blue, and 3 yellow. Okay, so the problem says we need, let's maybe call this P or something for total potions. We need 6, 7, and 3 as the number of potions. Can I explain why it's 3x? Sure, that's, so when you multiply x into this vector, you would get x, 3x, 0x, and then you add them all up together, right? Do we have to do all the steps, or can we go directly to the final thing? You want to explain your steps. And notably, if you go right to the final thing and you made any mistake, you get a 0 on the problem, right? Like that's really the risk you play. So that was a direct message, right? Like, can you go straight to the answer? Think about it like this. 1, you have to explain your work always. But 2, even if you didn't, if you go straight to the final answer and you made any mistakes, you get no partial credit, right? And so you just get a 0 on the question. And if the question is, do you want to spend 3 minutes writing out your steps and take the risk, right? And so you can spend 3 minutes and probably get partial marks, or you can save 3 minutes in a 24-hour exam and get 0 on the question. I think like between those two things, it should be obvious which one of those things you should choose, right? Okay, so direct messenger who asked me to explain the 3x, does that make sense? Right, because yeah, x times 130 is equal to x, 3x, 0x, right? Like that's what happens when you multiply a number into a matrix. You just multiply every number of the matrix by that number, right? Right, okay. Why is the first thing only R? Doesn't it include the value for red? Okay, right. Okay, so why is the top row R? Because in every single one of these 3 vectors, the top row is R, right? R is always the first element. If you think of these vectors as being a basket, the top number in each vector is always the number of reds. That's what we did. That's what we started by saying, right? Way up here. Right? We said the top number is the number of reds, the middle number is the number of blues, and the bottom number is the number of yellows. So always that top row is red, always the middle row is blue, always the bottom row is yellow, right? Yeah, and thank you, Faiza, for helping to answer Hamza's question, which is like the problem told you, if you go back and you look at it, it said you need 6 blue, 7 red, and 3 yellow. So I've just created this vector to keep track of how many of each potion that I need. Is a vector and a matrix the same thing? A vector is a special type of matrix, right? So all vectors are matrices, but not all matrices are vectors. Okay, see Aziz? Okay, so does that make sense? And so what I'm going to do is I'm going to set this vector that has all the x's, y's, and z's in it equal to p. And that's going to give us our system. And so this is our system of equations, and that was C. Okay, good. Yeah, that's what I like to see. I like to see that like epiphany. Oh, here, let me try and zoom out here so you can see the whole thing. I mean, it should look easy when I do it, right? Natalia, can you be like, are you asking the, oh, you want me to show the question, right? Yeah, I'll show the question again in a second. Just give me a second here. Angeli, where did the 6, 7, and 3 come from? Right, it came from the question. I'll show you, let me show you the question again, and this will hopefully answer some questions. Okay, so here was the question. And Angeli, the 6, 7, 3 comes from the very last sentence, which says, if you want 6 red, 7 blue, and 3 yellow potions, which linear system? Yeah, that's where it comes from. Yeah, sorry, C is what was circled. Okay, so hopefully you have that. Natalia, is that fine? Can I switch back? Okay. So this sort of setup, by the way, I tried to write this one out a little bit more explicitly than I might normally do. This is the sort of thing that you would want to give as a test solution, right? Which is explain to us how you set up the vectors, again, right, naming all of your variables and these sorts of things. And you can see here that hopefully you could just read through this and you understand what's being said. You don't just want to jump to the final answer, because if you do and you get it wrong, again, you're going to be in a lot of trouble, right? So does that make sense? Do people see like how, because this is, again, this is so much of what you're going to do is to take a word problem, figure out how to model it and create from that the linear system. And then I'm going to show you how to use a computer to solve that linear system very, very easily. Okay, so this is okay? In fact, I should say the following. Your third assignment is up already. And it's, next week is reading week. And so I don't want you to do anything in reading week, right? We're not going to like give you extra work or anything to do like that. But so assignment 3 is not due next Friday, but the Friday after because it's reading week. Now, if you look at that assignment, it has 2 problems that are very similar to this problem, which is take the description, this big old word problem, and extract from it the relevant information, and from that create the linear system. Okay, so like this is even directly relevant to the sorts of things that you're going to be doing there. Okay, exactly, Curry. Question 1 is basically exactly this, frankly, right? Yeah, I always hate people who are like, oh yeah, their reading week is free. Let's give them more work. It's like, no, that's not the point of the reading week, right? How do we type the vector on PC? What do you mean? Like, how do you, like if you were typing it, you could just say let v be the vector. Oftentimes we'll use bold to like a bold letter to denote a vector. Sometimes we put a little hat over it, sort of thing, like a little arrow. Yeah, it's possible you did. Absolutely, it's possible. Definitely some people have done linear algebra in high school. The thing inside the brackets is, well, okay, so once you, yeah, maybe I should elaborate this on a little bit more. Once 2 vectors are equal, if and only if, right? If I say that like, so these 2 vectors are equal only if their components all line up, right? So x has to be equal to a, y has to be equal to b, and z has to be equal to c, okay? So when I take this equation and I say, okay, well, what does that mean in terms of these 2 things being equal? That's the same thing as saying x plus 2z has to be equal to 6, 3x plus y has to be equal to 7, and y plus z has to be equal to 3. And that's where that linear system comes from, right? Inside of the brackets. Okay, so yeah, Connie, sorry, maybe I'm just not understanding what your question is. What do you mean, how do we type the vector? Like in a keyboard? Like I'm not 100% certain. It depends. Like you mean in LaTeX? Are you trying to learn the LaTeX version of this? Or like, how do you do it in Word or something? Yeah, I don't know how you're going to do it. You definitely need, if you want to type it, you want to learn how to do this in LaTeX. This is going to be hard to do in like Microsoft Word. Yeah, this is not going to be easy to do there. Yeah. Could the answer be written as an augmented matrix? 100%, Brandon. What a phenomenal question. So like if we were to write this as an augmented matrix, what would that augmented matrix be? So Brandon, thank you for this question. Everyone, let's take, and I'll still answer questions in the chat and stuff, but everyone take maybe like 30 seconds and see if you can write this linear system now as an augmented matrix. That's a great follow-up question, Brandon. Thank you. So when we get your system of equation, you have to go through the matrix. You don't have to. What we're going to learn, and what one of my objectives for you in this course is that every linear system can be described in like 4 or 5 different ways. And what I want you to be able to do is to very fluently move between every single one of these representations. Because I could give you a problem in one representation and you need to convert it into a different one in order to be able to solve it, for example. So that is one of my objectives for you. Here we have this system of equations inside of a vector. Brandon has said, hey, let's write it as an augmented matrix. So we're going to do that. That's a different representation. The linear system is one representation. We're going to learn a couple more. So I want you to be able to freely move between these without any issues. Right. Yeah, Louise, exactly. Yeah. We just draw a vertical line instead of the equals and remove the variable. Yes. Yeah, Rafid, that's exactly how you do it. Yeah, 100%. Right. So as an augmented matrix, And you don't just remove the variables, right? Because you have to put the zeros in now. You can't just, don't leave them as blanks, right? You actually have to put the zeros in. 3, 1, 7, 0, 1, 1, 6, 7, 3, like this, right? And again, the idea here is, you know, that first column is the x's, you know, the second column is the y's, you know, the third column is the z's. So kind of including them is redundant. The only interesting piece of information in this linear system is exactly what are the coefficients, right? What is the number in front of the x? What is the number in front of the y? What is the number in front of the z? So that's what the augmented matrix is doing for you. But you do have to signal where the equal sign is occurring. So you can separate your constants from your coefficients. And that's the purpose of that vertical line, right? That's what that does. If our original answer was an augmented matrix, yeah, I mean, absolutely, Kayla. If I asked you to just set up the linear system, then absolutely this would be fine. Yeah, this would be a great answer. I mean, you know, that wasn't one of the options. So in this case, you wouldn't be able to select this, but absolutely, that's a perfectly fine answer. Did I screw up? Yeah, 0. Sorry, you're right. Thank you. I see a lot of people getting upset about a 7. Thank you. And the second column has a, so 1, 3, 0, 0, 1, 1, 2, 0, 1. Okay, yeah, it's good now. Everyone's happy. And Ahmed, you mean second row, right? You want to be careful about that, right? Don't confuse rows and columns, because those are 100% defined mathematical words. And we might say to do things with rows and columns, and you want to make sure that you're very clear on which one is which when you write stuff down, right? Yeah, no problem. I mean, like that's an easy thing to screw up, but just be careful about it because you don't want to get burned on that. So direct message, say in an assignment or test, you mess up the normal linear system, but have the right augmented matrix, will we get full marks? Again, like it's going to depend on the question, right? It's really kind of difficult to comment on that outside of the context of what the question is asking you to do, right? So yeah, we'll have to kind of play that one by ear. But more importantly, instead of trying to hedge your bets about where you're going to get partial marks or not, just endeavor not to make a mistake. Because I mean, what difference does it make? Right? You're asking like, if I make this mistake, but get this answer, will I get part marks or not? Well, you're probably not going to do that intentionally. So what's the difference? You should just endeavor to not make a mistake. And if you do accidentally make a mistake, you get the marks that you get. So what difference does knowing that ahead of time make, right? Is it always row first, then column? Great question. Absolutely. Yeah, when we describe things, and we're going to see that later, I might describe a vector as like or a matrix as a 4x3. That's 4 rows, 3 columns. It's always rows first and then columns. Yeah. Okay. Okay, so far we've only done one question. I mean, it's an important question, but it's still only one question. So let's see if we can't get another one. This is going to be similar, but it's going to be, just a little bit different. All right, so let's try this one now. Okay, so I'm going to give you about 30 more seconds. I almost ended the meeting. That's not what I would want to do. Okay, so many people answered A, and then that was followed by C. A is the correct answer. C is almost correct. C is so close to being correct, it kind of hurts. C would be correct if what? What needs to change in C for C to be the correct answer? Exactly, exactly. If C had said it's equal to 2, the beautiful. I love seeing that in the chat. So many people. Yeah, absolutely. If C said 200, this would be correct. Now, what I'm going to do is you might have been able to get here like very, very quickly because the system only has 2 equations and 2 unknowns, right? So you might have just been able to see what the answer is. I'm going to go through this again fairly methodically and show you how to set this up as a complete linear system, just to give you an idea of what's going on. Okay, so this is question, what question is this, 10? Okay, so question 10, we know, let's again kind of read the question and extract the relevant information. So for cogs use what, 1 unit of work? Wait, which is first? Oh, widgets are first, right? It doesn't matter, but I'm just going to try and be consistent. So widgets are 1 unit of material and 6 hours. Right? Okay, and a cog is what, 2 units and 2 hours? Okay, exactly. Oh, I should have just read. Yeah, I should have just read what everyone was telling me in the chat. Sorry. Okay, now I'm going to do the same thing as I did before by making a basket. But those baskets, it might seem a little bit weird this time that in a basket, I'm putting both the number of hours and the number of units of material needed. But there's nothing saying you can't do that. So I'm going to say let's say unit cog denote, or sorry, unit hours denote the material and time requirements. Oops. Damn, this pen is doing it again. Can you hear that person laughing? Should I yell at them, tell them to shut up? I don't know, it's someone outside my window. Needed to produce. So for cogs, we're gonna get, I'm gonna call, or no, widgets. Widgets are first. Widgets, we're gonna get 1, 6. And for cogs, we'll get 2, 2. Right? They sound like kids. I mean, presumably, they're still my neighbors, so I don't want to yell at them. It does happen during in-person lectures, though, especially if you're in a small room and there's somebody standing outside your door just being super loud, and I have to go outside and be like, can you guys shut up and go away, please? Worse is during tests, right? Like if there's a group of people standing out in front of the door and you're trying to write a test and they're all just being loud, and as the instructor, I have to go outside and be like, guys, we're writing a test, get the hell out of here, right? So that sort of stuff happens all the time. Wouldn't the matrix then become x plus 2y 6x? Yeah, Ahmed, exactly, perfect, right? And I mean, yeah, I mean, like, sometimes you just don't realize that there are people nearby who are trying to do stuff. And that's, I never assume that people are being malicious about that. It's just sometimes you got to tell them, right? And that's okay. Most people are good about that. Okay, so now let's let X be the number of widgets we make and Y be the number of cogs. Okay, so the total number of resources that we need is then XW plus YC. Right, and maybe I'll write this. Should we always assume the items go in? It doesn't matter. So Curdy, in fact, if you did it in a different order, like let's say you did cogs first, then widgets, or you did hours on top and then units, we're going to learn it doesn't matter if you switch the equations around, right? Well, here, let me show you. Let me finish it and then I'll show you. Yeah, it doesn't matter if you switch the equations. And 6x plus y, like this, okay? And again, we need that to be equal to the total. We have what do we have? 100 units, 100 resources, units of resources, 200 hours of time. And so it's got to be equal to 100, 200. These are our two equations. Only one of those showed up. And if you didn't use X or Y, if you use different letters, that's fine. They're just names, right? I used X and Y because they showed up in the problem. Same thing if you'd reverse them and you used Y and X, it doesn't matter. Fundamentally, an equation is an equation regardless of what you call the variables inside of it, right? Now, note that if I'd switched everything and if I had done hours on top and units on bottom, then, right, if had done hours and material, and you go through it and you, yeah, sure, just give me a second. And we were to go through the whole thing again, we would get exactly the same thing, just, you know, kind of upside down. Okay, so it doesn't make a difference the order that you do them in. It's just that once you fix the order, make sure that everything after that preserves that order, right? If our working, okay, so I've got this question. It's a direct message. If our working is a bit less detailed compared to yours, will we still receive full marks? It's the typical sort of writing thing. Your goal is to be clear. If your answer is clear, you get full marks. If it's more detailed or less detailed, it doesn't matter. Your objective is clarity, right? I can't provide for you a template to say this is how you write every single question, right? You can't do that. You have to use a little bit of your own discretion, but like your goal here is clarity. And if what you're doing is clear, you should get full marks, right? That's it. And that's part of what we're trying to do with like the writing assignments as well, is to get you used to, you know, presenting things in a clear way. Okay, now I've fallen behind in the chat, sorry. Could you show the question, please? Sure. And then while the question is up, I will keep reading. It's 2y for the bottom of the matrix, right, Jack? Yeah, maybe I made a mistake. I'll check that in a second. But it can't be hours and units combined. Correct. So I got a direct message saying, can it be like units and hours combined? No, you kind of have to separate them, right? They're two different resources. It's like when we were talking about the potions in the previous problem, there were blue potions and there were red potions, and I really want to keep them separate because, you know, the question asks me to do something with red potions and blue potions, not just the total number of potions, right? So if it's appropriate to keep something separate, you usually do want to keep them separate. Okay, so yeah, a couple people are getting upset. So I must have made a small little mistake here. X. Okay, so hold on. Where is this 2 that I've screwed up? You put a y instead of a 2y. Oh, I see. You're right. Thank you. Yeah, thank you. Can it be material over hour instead? Well, Jacob, that's how we actually did the problem, right? Oops. Right, we did units over hours or material over hours, right? Like maybe I'll call this material instead. It's a little sloppy, but yeah, that's how we actually did the problem. So you can totally do it that way. So the rows of the vector are unit hours or material hours. The rows are neither. The top row is of the original one. The top row is materials, and this is hours, right? Or maybe that is what you asked. So the rows of the vector are hours, or right? Okay, yeah, sorry, Davin, that is what you asked. Yeah. And then in the bottom one, they're flipped, right? It's the other way, but exactly, you're right, yeah. What if this was multiple choice? What would you ask to find the first equation, for example? No, because I wouldn't ask for the first equation because first is meaningless. It's not well defined, right? It's up to you when you create the question to decide what the variables should be. Even there's some even poor definedness in the fact that we didn't say what X and Y should be. And so we were kind of relying on you to use those variables, but I would never ask something so poorly defined, right? I wouldn't say find the first equation because there is no first equation. It's up to you what the first equation is, right? Find the system of equations for materials, though. That's a perfectly valid question. Yeah, 100% we could, I wouldn't say system of equation. I would say find the equation which describes the materials. Yeah, 100%. That's a fair game question. Yeah, that's a good thinking. Yeah. Can I put everything in a table so I don't get confused? I mean, too, I'm not going to tell you what you can and can't do. If you want to use a table, especially in the early part, like if you want to use a table up here and you want to do like widgets, cogs, and then like material, and then hours, like go crazy. That's a great little organizational tool. 100% you should do this, right? Like 1, 6, 2, 2. Yeah, go crazy. So do what you want to do. You don't have to ask me for permission. If something helps you do it, if you do something weird though, just make sure you explain it, right? That's kind of the rule. If you do something that's weird, explain it. What I would probably do is I'd say, let me sort this information into a table. Then I draw the table. The table is evident from that point, and then you could write down what you wanted, right? Okay, are there any other questions about this? We only got to 2 questions here, but I think like these 2 questions are the 2 most important. So we missed a couple things about linear combinations. That's not a big deal. I'll post the solutions tonight. We could do another one. I'm totally fine with that if there's enough demand. I don't have another modeling one though. The only other ones I have to do with linear combinations. So it just comes down to whether you want to do linear combination problems. Yeah, what? Another one? I mean, I show you, and then we can do, but okay. But yeah, I don't have another modeling one. So do people just want another question? Again, under the knowledge that I don't. Okay, sure. Yeah, I'll give you another one. Let me see here. Let's not do that one. We could do that one. Yeah, let's do this one. Right on. Yeah, I love that. Relaunch. Bye, Faiza. Have a good reading week as well. Good luck on the test. And you sniped the answer. So Caitlin, the test will be in the test information page. So the interesting thing there is if somebody sends me a private message, it automatically changes my chat thing to send a private message back. So as I was going to hit enter, I got a private message from somebody else. And so I sent that message directly to them. For the test, how would we know which formula to use? Unfortunately, part of that is part of the problem, right? Is you have to be able to identify what things to do when. I would caution against thinking about things as identifying which formula to use. I think a lot of you have seen the sorts of questions that we are inclined to ask. And you know that the questions that we tend to ask aren't usually plug things into a formula, but rather find the formula, right? So, just kind of be aware of that. But yeah, I mean, part of, if there is a formula involved, part of that is your responsibility is to figure out when and what formula you should apply when. Yeah. All right, for those of you who have to run, see you later. And by later, I mean in like 12 days or whatever. Okay, yeah, we're at 2/3. I'll give you like 20 more seconds, get your answers in. I love this though. This is phenomenal because yeah, there's a lot of right answers here. Just to be sure, no ID have to be uploaded. No ID at all. Don't worry about it. It's supposed to be a thing that prevents you from like paying somebody else to write your solutions for you and updating because they wouldn't have your ID. But that's such a trivial thing to get by, which is you would just take a picture of your ID and send it to the other person to upload for you, or they would send solutions to you and you would upload them. Like, it's such a stupid thing that whoever thought about doing this just clearly hasn't thought about how you would cheat, right? Like, it's so easy to get around. Okay, let's end this and share. All right, so overwhelmingly, everyone said C. And C is absolutely the correct answer, which is a great job. Now, remember, what does it mean to be a linear combination? So which question is this? This is question 12. I have a funny story about calculators that if you remind me to tell you, I'll tell you about me getting angry at like management and econ. But anyway, so we've got these vectors V1, which is 1 to -3. And we've got V2, which is 2, 0, -2. Now, in this case, there are few enough terms here that you and the the vectors we chose are usually such that you can eyeball what the answer is, and that's kind of the hope, because we haven't taught you how to solve this system yet. But the hope was just that if you understand what we're asking, that you could eyeball the answer. So we're asking, so you want to know if there exist C1 and C2 such that C1, V1, maybe let me put a little arrow vector over that. The given vector, right? This is what it means. The correct answer, yes, is C, yeah. Okay, so that's what we're asking is for each of the vectors that we gave you, if you were to put it into this spot right here, are there C1 and C2 which make this possible? And so I think, again, we're eventually going to teach you how to actually do this, but for now, we're just kind of doing it by inspection. So the first vector we gave you was 3 to -5. So can anyone tell me what the numbers I should put here are? -2, like that. 1 and 1. Okay, does everyone agree? So if I just add these straight across, I get 3 to -5. Okay, cool. B 4, 0, -4. What do I do? Man, that is a loud squirrel. 0 and 2, exactly. Everyone agrees? 0 and 2 works. And remember, you're allowed to use 0, right? 0 is 100% fair game. Now, I said C is the correct answer. And we could probably get that by process of elimination, but it's actually possible to check that C is impossible. So I'm going to skip that. I'm going to do D first. 4, 4, -8. You know what I'm going to ask, so you can get ahead of me. G0, -2. All right, what are the numbers? 2 and 1. Everyone agrees? Yeah. Okay, cool. And so by process of elimination, it has to be C. Now, if you didn't want to do it by process of elimination, I mean, unfortunately, you kind of have to check them all. But what you could do is the following. Let's call that C1 and C2. Does C have to be an integer or could it be a decimal? It 100% could be a decimal. In this case, because we wanted you to do it by inspection, we weren't going to choose ugly numbers, Brandon. But as a general rule, absolutely, they could be fractions. They could be decimals. One of the numbers could be pi. That's totally fair game. Once we teach you how to solve them, then you'll be able to do that. But right now, we just chose nice numbers just to make it easy, right? How are we getting the two numbers we're adding? Just so for the direct message that was sent, it's guess and check. Like people are looking at it and just guessing what the number should be and hoping that they see what the pattern is. But actually what we're about to do now might give a hint into how we would do this. So we can say with 100% confidence what C1 has to be. Does everyone agree? In this, so if we're looking at problem C, what is C1? Have to be. It has to be a half. Does everyone agree? Because if you look at, because if you look at the second entry of the second vector, it's 0, right? So no matter what C2 is, if I look at this thing right here, when I add these two things together, only C1 affects this vector, right? So that tells us C1 has to be a half. Okay, so if C1's a half, let's plug that back in. What do we get? So we're going to get 1, 1, 1 is equal to 1/2, 1, -3/2 plus C2. Okay, and now if you look at the top equation and the bottom equation, we get that and 1, and -3/2 plus or minus 2C2 is equal to 1. And that can't be true. There is no value of C2 that makes this true, right? And so there is no solution. So if you wanted to do it kind of directly without doing process of elimination, this is how you would do it. Until I teach you the better way, which I will very, very soon. Notice as well, this is actually a linear combination problem, right? If you were to write out the linear system here, you get C1 plus 2C2, 2C1, and -3C1 minus 2C2, right? So it's possible as well to translate between being a linear combination problem and being a linear system. Okay, I'm actually gonna close this window because those birds. All right, so a linear combination is another representation of a linear system. And again, I want you to be able to freely translate between this. And this is actually assignment 3 question 2, right, is asking you to do this sort of thing. So are there any questions about this? For scalar multiples, can it be a negative number that you multiply by? Absolutely. Yeah. So if you do like -3 times 7 for pi, yeah, that would absolutely be -21, -12, -3 pi. Like that's totally okay. You can definitely multiply by, you can multiply by any real number. So negative numbers, fractions, decimals, weird numbers like pi, square root 2, absolutely. Yeah, anything you want. Okay, we're good. Okay, so what I'm going to say here, this is probably a good time to stop because I know there's a bunch of you who have financial math problems. Give me a couple of minutes, again, just to give me a little bit of a break and go fill my stuff. I'll come back and then I'll answer your financial math questions. Okay, so give me like 2 or 3 minutes here and I'll be right back. Okay, everyone, I'm back. Just to a couple of things. Jacob, why do you need the TA emails? And then there's a question here, which is a direct message, which says, will the course still be delivered online in the winter or fully in person or half online? I'm an international student and I'm worried because, I might have to go back to Toronto. My mentality here is I am super ticked off that the university is even considering changing this because I think it's very unfair to our international students, and not even international, domestic students who might not be living in Toronto. Like, if you live in Montreal or something and you've set up a lease to live in Montreal, it's a dick move to ask people to come back. What I will say is the following. I have effectively a guarantee from my department that because we started online, we will stay online the entire year. What I expect will happen, and we're still waiting for more messaging because we don't have any messages from up on high about, they just basically came out and said, yeah, we're going as much in person as we can, and didn't tell anyone. Like my chair doesn't know. And so what we expect is maybe more options for people to attend in person if they want to, but still being able to participate online if you want to do that. So I think it's just a matter of options, but I'll let you know more when I know more. The answer is I don't know more. My chair doesn't know more. There's been very little messaging on this, right? So we'll let you know more about that when we have something to tell you. All right. So hold on. All right, I'm getting my butt kicked here. So Shanze, question 1, right? Okay, so question 1 from that thing you just sent me. Let me just write this down somewhere so that I've got a big old list of all the things that we need to do. So Q&A that tutorial. For the questions, pages, answers from tutorial, Jacob, I don't know. Maybe I missed an earlier message. You should email Aziz. I think Aziz is probably your best bet for that, Jacob. And Aziz's email can be found in the remarking thing. So his email is there. So if you want to bug him about that, you could try. Yeah, full year, exactly, Ain. Yeah, full year is going to stay online. I got the email about that, but I'm really nervous. Like I said, let's see what happens. I don't think there's any reason to worry about it right now because we just don't have any messaging. So let's not worry about it quite yet until we find out whether or not we have to, right? Because right now there's nothing we can do about it until we know more. Do we start the test at 9 a.m.? No, Tina, we're going to start it in 3 hours. If I'm still doing the practice after 9 a.m. but doesn't open the test question in CrowdMark, is it an academic offense? I don't know quite what you're asking. The questions are going to be posted as a PDF, and you will have access to that PDF for 24 hours, and then you will write your solutions, you will upload them to CrowdMark, and that's it. Like, nothing else about that. Oh yeah, and you corrected 9 p.m. Sorry, maybe I just hadn't read low enough. An email went out 40 minutes ago saying this number will increase considerably with the majority of classes occurring in person. Yeah, we'll see about that. I don't know. Again, if the dean tries to force us and most of us don't want to do it, we're going to see how that goes, right? Because again, like, what are you going to do, right? If the dean's like, yeah, you're going to teach in person, I'm like, no, actually, I'm going to teach online. You know, try and force me. Let's see how that works. Exactly. And again, because here's the thing, I know there are people who really want to go back to in person, and for them, I think they will have the option. But for anyone who wants to stay online, I think you should also have that option. Okay, Shanzeh, I'm sure is getting a little bit fidgety that I haven't answered the question. Will this test be very difficult? I don't know. I didn't think it was difficult, but I'm not a good metric of that difficulty. I had the TAs solve it, and they thought that it was straightforward. So, take that for what it is. Okay, so the tutorial, you know what, maybe let me share my screen here so everyone can see what the question is. So I'm just gonna share here. All right, so here was the question that was asked. Oh, why is that? And question 1. Yeah, I agree. I think it's a jerk move. Okay, so it's January 1st, 2021. Asan's parents would like to set up an annuity which pays his tuition for the next 4 years. So for those of you, if you don't have this, I would take a picture of it because I'm going to take it off my screen in a second. Suppose he needs to withdraw $R at the end of each 4-month period to prepare to pay his tuition. This means his last withdrawal will be August 30th, 2024 to pay for his fall 2024 term. Assume the stated APR of the annuity is R greater than 0. And I assume we're going to assume, it gives us the different compounding rate. Determine the present value of the annuity if it's compounded monthly. What is the least amount of money that Asan's parent must invest? Good. Suppose that Asan's parents are very generous and wish to continue providing you. Okay, cool. Suppose that Asan's parents set up an annuity, which instead offers continuously compounding interest at a rate of R to cover the tuition for 4 years. His parents should. Okay. Said one of the TA, the assignment popularity is given is harder than the test. Yeah, well, hopefully that's true. Okay. Let me stop sharing. Okay, so let's do this. Hopefully you manage to get like a picture of that, or hopefully just have it somewhere. So there's a lot going on here. Let me just shrink the chat so I can see it. All right. So it's January 1st, 2021. We're going to make payments. Right. Okay. So let's timeline, always, right? So tutorial Q1. So we're going to make a timeline. And let's just plot out a year so we can see what's going to happen, right? So here's January 1st. And then the kind of important payments occur April, August, and December, right? So here's April, here's August, and here's December. Well, maybe let me include the other months. So January, February, March, April, 1, 2, 3, 1, 2, 3. So January, February, March, April, May, June, July, August, September, October, November, December, like so. Is the 1% bonus question similar to the test? I mean, they're multiple choice. So I mean, only to an extent, right? Okay, so we're going to have payments occur here. Does it say at the end of the month? Yes, so it's going to be at the end of each month. Are the payments. So question A says that if we're compounding monthly, what's the present value of this thing? Right? Okay, so as always as everything, we've got these compounding events here. Now, it is quoted as an APR, right? It's quoted as an APR compounding monthly. So these aren't an interest rate R. These are actually, each of these here is an interest rate R over 12, right? And so on. Okay, I don't want to write out R over 12 a million times, but you know that that's true, okay? And they were not clear when they made the question whether the compounding occurs at the beginning of the month or the end of the month. So I'm going to assume simultaneous compounding, in which case, if you make a withdrawal payment at the same time as a compounding event, you don't pick up the compounding event. They might have a different assumption, but that's the assumption I'm making. So let's start pulling payments back. What's this first payment? The April payment. When I pull that back, what do I get? Right, or in this case, P, right? Because I'm using P. To the -3. Okay, and the second payment, the August payment. Oh, does it say R dollars? Oh, you're right. I should use R then. You are 100% correct. That's on me. Okay, and so the second payment. 8 seems, let me just double check. That to me seems like 1, 2, 3, 4, 5, 6, 7 to me, right? Yeah, okay. Yeah, I'll assume it was a like just a typo. 1 plus R to -12 to -7. All right, let's do one more. Okay, so Curdy, just kind of like jumping the gun there, but I like it. All right, and we get R 1 plus R over 12 to the -11. Okay, now we're going to do this for a total of 4 years, right? So the total present value is going to be R 1 plus R over 12 to the -3, R 1 plus R over 12, -7. R over 12, -11. And the question is, what is the last one? Why is it -4? Okay, sure. Yeah, great question. So I'm assuming, and that when I take this back, it is only going to see these 3 payments. Okay, because I'm assuming that the compounding event happens at the same time as the withdrawal, and therefore that payment won't see it. If you want, you can do this problem where it will see it and it will change your answer a little bit, but I said at the beginning I was going to make that assumption. Yeah. Okay, so apparently I got a direct message saying that one of the TAs did it with the -4. So again, in that case, I would just be a little bit clear and say that the compounding occurs at the beginning of the month, in which case that would pick up the -4. And that's totally okay. Let's do the question like this though, and let's see how it goes. Right? Yeah, so you could do either. Again, I will be very clear in a test where the compounding event occurs, whether it occurs at the beginning of the month or at the end of the month. And in that case, you'll be able to determine exactly whether you pick up 3 or 4. Does that make sense? Is everyone okay? Like, do you understand what I'm saying by like my wording will be clear? Okay, cool. So what's the last payment after 4 years? 15, what? 43 seems too low to me. I think you're just off by 1, Curdy. Is it 44 and I'm just crazy? No, I think, was it -40? Okay, let's just work it out. So The next one will be negative 15. That looks like negative 15. Negative, oh, maybe I'm thinking of something else. Negative 19, negative 23, negative 27, negative 31, negative 35. So that's 3 years, negative 39, negative 43. Am I crazy? Well, okay, so it would have been 44 in the tutorial because they assumed perfect division, right? Of again, they would have started with 4 here and then 8. So that's why they would have gotten not 43 or 47. But I think the last payment is the 47th payment, right? And in fact, even in your tutorial, was the first payment on the first day? No, it couldn't have been, right? Because the first payment is in April, not in January. So it should have ended at 48. In tutorial, it should have been 48. Doesn't the 4th year only have 2 withdrawals? Why? Oh, because you graduate. No, hold on. This is true. Because you graduate in, but then wouldn't there only be 1? I don't even think it ends in August. Why wouldn't it end in April? And under a standard thing, you would graduate, but why August? Does it say August? Oh, damn it. It does say August, son of a gun. It does say August 30th, 2024. Sorry, I'm not reading the question strong enough. It is 43. Yes, thank you. See, I would have lost marks there because I didn't read the question carefully enough. Yeah, thank you. Okay, so 43 is the last one. Yeah, you're absolutely correct. Okay, everyone agrees 43 is the right answer then? Thank you. I now know better than to doubt any of you. You're absolutely always correct. Okay, so if I want to write this as a sum, the sum, what is our common ratio going to be? I'm going to put it R, 1 plus R over 12. What do I want to put upstairs? Okay, so, ooh, Brandon, I like yours. Let's do, but why 2n? That's my question. So let's first factor out that first term, right? That's the 1 plus, that's the negative 3, right? That's the first term. Now, what's the common ratio? Basically, common ratio is what is the exponent changing by every time? All right, everyone, hold on. Remember, if you're not certain, don't guess. Okay, you don't want to guess. Yeah, exactly. Jeremiah, thank you. And how would we do that? We're going to take any term that we want and divide it by the previous term, right? So if you do divided by r times 1 plus r over 12 to the negative 7, you would get 1 plus r over 12 to the negative 4. Okay, don't guess. Just make sure you actually do that and arrive at your answer that way. Okay, and the first value of k is what? 0, very good. And the last value of k is what? 10, beautiful, perfect. Okay, everyone's okay? And then you go and you plug this into the equation, all right? For the present value of an annuity, or like the formula for a finite geometric series. When it's written in sigma notation, I mean, you can factor out, Jacob, you can actually factor out anything that doesn't have like the k's implicit in it, like this. All right, and then you just plug this into the formula. Mm-hmm. Exactly. Basically, anything that isn't the common ratio can be pulled out. Why is it 10? Okay, so I got a direct message asking why it's 10. So note, and actually somebody who said earlier the 2n minus 1, Brandon. So Brandon, actually, from here we can see that the answer should have been negative 4k minus 3 is actually the one that we want. Because if I were to combine those exponents, okay? Oh, yes. Oh, sorry. And then you literally just wrote that. So yeah, exactly. Negative 4k minus 3, and that would have been absolutely correct as well. Okay. So, but the problem with writing it as the 4k, negative 4k minus 3 and is that you still have to do the factoring out when you actually want to apply the formula, right? Because you don't, that exponent just needs to be basically something to the power of k, not that negative 3 is in the way there, right? But exactly. Does it look like a, oh, it does look like a 45. You're right. My pen probably just died a little bit. Okay, so the question is though, where did the 10 come from? So if the question is, basically r times 1 plus r to the negative 3 times 1 plus r to the negative 4k is equal to r times, this is the last term here, right? To the negative 43, what value makes this true? So this is a direct message for some of you wondering. And the question was like, how do we get k equals 10? The question is what value of k makes this true? And if you look at the exponents, you get negative 4k minus 3 equals negative 43. And if you were to actually solve that for k, you would get k is equal to 10. And so that's how you figure out the top number there. Okay, so does that make sense, person who direct messaged me? Do you see how I got that? Okay, perfect. In tutorial, we separated the 4 and the k. Should we still do that? Well, yeah, I mean, if you want, it doesn't make a difference. So I did it like, these are the same thing, right? And this just allows you to really correctly identify what the common ratio is. I assume that's what you're talking about, Jacob. So this just allows you to really see what the common ratio is, but at the end of the day, it doesn't make a difference. As long as you're kind of comfortable either way, you don't have to do this if you don't want to. Can you explain how to solve a question that has a deposit that is made each year and the APR is compounded continuously? Sure, so that's part C, so I can take that up in a second. I don't get why we include the first equation and not just the common ratio. Oh, so, okay, let's think about it, because this is a good question. So if we just include the common ratio, so actually the common ratio is just this, right? So if we just include this and I plug k equals 0 into this, I get 1 plus r over 12 to the negative 4 plus 1 plus r over 12 to the negative 8 plus ... And if we compare, okay, I want you to compare now this equation with this equation. And even if you look at that first term, you'll notice you don't want it to start with a 1, right? You actually want it to start with r times 1 plus r over 12 to the power of negative 3. That's where the 1 plus r over 12 to the negative 3 comes in, right? That's me including that in the first term. Yeah. And Shadze, exactly, yeah, because we start at 0. Because we want to start at 0 in order to be able to use the formula. So we want to factor out that term from everything. Does that make sense? Okay. Sorry, maybe we look at the timeline again and why what we're doing. Oh, okay, so sure. So here's the timeline. And the difference is that in tutorial, they were including this compounding event in R. Right? And I didn't include it because I assumed they occurred simultaneously. So if we said, for example, that you compounded at the beginning or at the, let's say, yeah, or alternatively, if we compounded at the beginning of every month, it would also have been 4. Okay, but again, Davin, like we'll be very clear in the test where the compounding event occurs relative to the payment. So there's no ambiguity in that. Okay, we'll be very, very clear about that. Okay, is that good then? We've kind of got that sorted out. Okay, so there's a question about continuous. Now, part C of this question is continuous. So suppose that Islam's parents set up the annuity, which instead offers continuously compounding interest. Should his parents choose to invest? Well, okay, so it just asks whether you should invest, but we can just set it up, right? We can actually just do it. Yes, yeah, Theodora, the common thing is if you compound at the same time as a deposit is made, the deposit does not see the compounding interest. Now, there is some ambiguity in that, which is why we've kind of stopped doing that for this class, right? We've said we're going to make it very clear where the payments and the compounding events occur so that we don't have to worry about that simultaneous ambiguity. So, like I said, we'll be very clear about that. But traditionally, if they occur at the same time, the payment does not see the compounding interest. Okay, so let's do the same problem because somebody said, like, how would we do this if we had continuous compounding interest? So let's do exactly the same problem, but now continuous compounding interest. So again, let me just draw the timeline. I have P. This here is the end of April. This one's the end of August. And this one's the end of December. Okay, and still our rate is R%. Can I zoom out? Sure. That's too much. Like that. Okay, so while we're doing this, somebody take a second and, like, if you're anticipating the continuous compounding interest, no problem. You know, start the question without me. Like, you don't need me to start off. Excuse me. So I've got this is a year, and I've got these payments P, and I'm compounding it at an interest rate R. Now, so we're going to do exactly the same thing. I'm going to bring these payments back to the present, but I'm now going to use continuous compounding interest. What is the value of this payment here? Anyone? Close, Curdy. So, okay, yeah, so right, you picked up that it would be negative R, but now e to the negative R is what happens when you pull back an entire year. And Agam, I think you missed the divided by sign. Christian, yeah. Jeremiah, that's for every month, right? And we've pulled back 4 months. Okay, so everyone remember, e to the negative R here, this is, I think, a point that's worth making because I think there's a little bit of confusion about it. This, again, I keep using P instead of R, sorry. R e to the negative R, so the e to the negative R term brings it back an entire year, okay? And then R e to the negative 2R would bring it back 2 years, okay? So the number in front of the R there is telling you how many years have passed. Okay, does that make sense? Exactly, Ariana. And that actually agrees with Christian's answer above too, right? Because 4/12 is equal to 1/3. Yeah, exactly. So we're bringing it back 1/3 of a year, or we're bringing it back 4 out of the 12 months of the year. So we would get e to the negative, how do I want to write this? 4/12 R. Okay, and you can simplify that if you want. I think it's going to make more sense just to leave it as 4/12, and you'll see why in a second. But absolutely, it's e to the negative 4/12. So is everyone okay with that? Because if we get that, the rest we can probably do. Yeah, we'll use sigma notation too. No, we're going to use sigma notation because we do have multiple payments. Basically, the moment you have multiple payments, sigma notation is the right thing to do. So let's do the next one. Okay. Oh yes, lowercase r, thank you. I am a little bit fried today. I've just been working for so long. So the next one is, perfect, right? We pulled it back 8 months, like so. Everyone agrees? I need to learn how to drink because I keep misdrinking and I have to cough. Okay, everyone's good with that though? Everyone agrees that Curry's answer here, e to the negative r 8/12. Okay, and the final one? Well, okay, yeah, okay. That would be the final one, Curdy. Yeah, I meant the last one for this year. But you're right, that would be the final one. And then Jacob, negative R, right? Though, right? Because you're pulling it back into the present. Yeah. Okay. And then again, let's think how. So our present value is going to look like PV equals R e to the negative 4/12 little r, R e to the negative 8/12 r plus. And again, let me write this as 12/12 r. And then our final payment, as Curdy said, is 44/12. Exactly, it's 12/12. It does become 1, but Curdy, I actually want to leave it as 12/12 so that when I write it in sigma notation, it's a little bit easier to figure out what to do. If I wanted to write everything in terms of thirds, it would have been fine as well. But yeah, you'll see why we want to leave it as like 12/12 or 1/3, 2/3, 3/3. Okay, and as kind of said, the last one occurs in the 44th month, right? We're going to pull that back, e to the negative 44/12r, like that. Okay, does everyone agree that's the last payment? Exactly, Shanzi. Yeah, we're doing parts a year because there was people wanted me to do a continuous compounding one. So, yes, Connie. Yeah. Okay, everyone's good. So now, okay, now let's write this as a sigma notation. So what's the common ratio? Exactly, negative 4/12. Okay, and if we want, we can write it like this, right? And where do we start? K equals, what's the first number? Yeah, Brandon, exactly. 1, perfect. Last one, 11. Beautiful. And if you want to, at this point, simplify the 4/12, you can, then you can write it as 1/3 instead. The reason why I'd recommend you kind of keeping it in terms of whatever the denominator is like, let's say I had done every 3 months instead of every 4 months, we would have gotten a quarter, a half, 3/4, 1, and the pattern might not have been as easy to see. Whereas if you leave everything in terms of 12ths and then only simplify the fraction at the end, it becomes a little bit easier to see what the pattern is, okay? And then you can go and you can plug this into your formula for a finite geometric series, and you have your answer. You're done. So if they withdrew on December 2024, exactly, Christian, exactly. Yeah, it would be 12 instead of 11. Yeah. Why is it? Oh, you're right. I forgot the R. Thank you. 4/12 R to the K. Thank you, Jay. You can. So I got a direct message saying, don't you need R e to the negative 4/12 R on the left of the sigma? It depends on what you want to do. So this, normally our formula for a finite geometric series starts at 0, right? And this one starts at 1. If you wanted to, what you could do is you could actually factor out the first R e to the negative R/12, and that would actually get your sum to start at 0. Like that. So if you wanted to do it like that, those are the same sum, and lets you start from 0 instead. Yeah. So which bank do we choose? I mean, you don't want to, or you want to choose the one that means that you have to invest the least amount of money today, right? So everyone, which bank do you want to choose? So do you discount more continuously, or do you discount more monthly? Like which? which of those payments will be less, which has the smaller present value. Exactly. Okay, wait, yeah. So remember, Jeremiah, the opposite, if you compound continuously, you actually make more money, right, than if you compound monthly. And so that means if you're moving forward in time, continuous makes more money. And then that means that if you pull it back in time, then you actually discount more, right? You take more money off. So you want the least, in this scenario, you want the least present value because you want to have to put the least amount of money in. And so in this case, you would actually want the continuous. Okay, like think about it like this. Alternatively, they're making the investment, right? Like let's say they put $20,000 into the bank account or whatever. Instead of thinking about it in present value, you would say, like, which do you want your money to compound at? Do you want it to compound, if you were to push it forward, do you want to compound monthly or continuously? We know the answer to that is continuously, right? It's just that things are kind of weird because we're pulling things back to the present, but we know because that's my money that's being invested, I want it to invest as much as possible. So if you want to think about it from that perspective, you'll see that continuous is the right answer there as well, right? Really said to pick the monthly. Let me read the question carefully because I've been burned on this before. Suppose the ASN parent set up in the annuity with the bank of MAT133. Okay, how about this? Do you all agree that if the present value is how much you need to invest to cover the payments, right? So do we all agree that you want the one that has the lower present value? Yeah? Okay. Choose numbers and actually compute both of these things and tell me which of them is lower. All right. And you're going to see that the continuous one is lower. Yeah. Okay. So TA might have made a mistake there. The previous mistakes were definitely on me for not reading the question carefully. But this one, if you do it, you're going to find that the continuous rate is the lower rate. Does that make sense? Did the TA give an explanation for why they chose monthly? Shanze, yeah, I think if I ask you this question, say on a test, you can plug in numbers to help you figure out what the right answer should be, but your explanation needs to hold without numbers. Does that make sense? Brandon, do you remember what the TA said? So I can try and see where they obviously might have made a mistake. Okay, that's fine. Well, in this case, you could either say it mathematically. You could say, look, e to the you could try and convince someone that this is generally less than this. Right? Or what you could do is you could say exactly what I said a little bit earlier, which was the exponential, because it grows the fastest, also discounts the most when you compute its present value. So because it discounts the most, the present value with it will be lower, and therefore that's the one that we would want to choose. So if you do a financial explanation like that, that's how you would explain it. Can I show the finite geometric series as well? Sure. So you're asking me to actually plug it in? Is that what you're saying? For a person who direct messaged me? Yeah, okay, so if I actually plugged this in, and Curdy, I see your question, just let me get to it in a second. So we know that the sum from k equals 0 to n of r to the k is 1 minus r to the n plus 1 all over 1 minus r. So if I plug this in, negative 4 over 12's r times, now this is the part where I actually plug it into the sigma notation, 1 minus e to the negative 4r over 12 to the power of 11 divided by 1 minus e to the negative 4r over 12, like that. And there it is, right? I would probably, I would simplify that, the numerator a little bit by actually multiplying the 11 in, but I don't need to go much further than that. he said to us, these are the same withdrawal from a timing perspective. They have different computing schemes, but measure the same withdrawal time. That is very confusing. I'm not certain what that's supposed to mean. Yeah. We have to invest which has the lower present value. So this is an important question, which is, if you're the one who has to make an annuity payment, which do you want? Do you want the lower present value or the higher one? So, okay, think about it like this. Suppose you are Ehsan's parents, right? And you are putting a big chunk of money into an investment account in order to cover his tuition. Do you want to pay more money or less money? Right? Because that's what the present value of the annuity is telling you. It's how much money do I need to put into that investment account for me to make sure that Ehsan has enough tuition to cover all those payments, right? And yeah, you definitely want the smaller present value, right? So the thing that you want there is definitely the lesser of the two numbers. I mean, if you, on the other side of things, if you were, the bank making the investment for this person, like, let's say you were buying an annuity from the bank. If you're at the bank's perspective, you want the present value to be as big as possible, right? Because that's the money you're getting. Whatever's good for one party, who is ever on the other side usually wants the opposite. So it's important to keep the perspective of which person you are, right? Do you want a lower number or do you want a bigger number? You want to pay the least amount of debt, but if you're the debtor, you want the other person to pay the most amount of debt, right? So you have to keep in mind what the context is. 212 from the notes. Sure, let me pull it up. Just give me a sec. This might have to be the last one I do. I do have a hard out at 7 because there's stuff I got to do before I post the test. So I think this will be my last one, everyone, and hopefully I answered most of the questions, or at least did interesting enough questions that it helped. Suppose an investment compounds at APR 5% monthly. Find the effective daily rate. The ad is the APR. Okay, sure. This is a great question. So this is 212. So you have an APR of 5% compounding monthly. Okay, anytime you do any of these questions, you usually want to look at how much money they make over a year. So a payment R after 1 year has how much money? According to this thing, has like how much money did that earn after 1 year? Yeah, exactly. Perfect. Okay, does that make sense, Shanzai? Do you understand that portion? Right, because there are 12 compounding periods. Okay, beautiful. Now, what the question is asking you is to find the effective daily rate, okay? i.e. R sub D is saying you compounded at an APR of RD, or maybe let me say APR of RD daily. Okay, how much money does that earn after a year? Nominal rate, does that mean APR? Yes. Yeah, all right, yeah, you can take it to be the APR. No problem. Daily rate means R over 365. Yep, it's an APR of R sub D compounding daily. So how much money does this make after a year? Okay, sure. Yeah, perfect. And this is R sub D here, right? Why are we not? Right, okay, because we don't know what this D is. This R sub D is the thing we're trying to figure out. What we're gonna say now is these two things are equal. And we're gonna try and figure out what RD is. Davin, yeah, perfect, exactly, right? So the effective daily rate is saying it's the rate, it's the APR at which if you compounded daily, you would get the same amount of money as 5% compounded monthly. So this is why we set these up as two different things. We said, what is 5% monthly? Oh, that's the first equation. What is RD compounded daily? Oh, that's the bottom equation. But we don't know what RD is. That's what we're trying to figure out. So we're going to set these two equations to be equal, and then we're going to solve for R sub D. Does that make sense? How we actually did that, how we got that? Right, and that's how you do it. So I'm going to leave the solving for you, right? Hopefully you can do that. It's algebra. You take like a 365th root, in order to solve for it. But that's what that means. And so you could imagine now, if you want to practice, I could have said, what is the effective weekly rate, right? So what is R sub W, such that if I compounded weekly, I would get the same answer. Yeah, exactly. So you do the same thing, right? Using 52 this time, and then you would solve for R sub W. And so that's how you would do that question, no matter what compounding period I gave you. Okay, everyone good? You could take logarithms. Absolutely, logarithm is something you could do. Jack, I might do something like there's a couple ways you could do it, but logarithms are definitely one way. Maybe, yeah, this should be 0.05, right? Lons would work. Another thing you could do is you could just raise everything to the 1/365th power like this. Right? And then that would get rid of that exponent on the right-hand side for you as well. But logarithms absolutely would work if you wanted to do it that way. So try it both ways and see which way you like more. Okay, everyone, like I said, I kind of have that hard out at 7, which I know is probably not the best because it's the day before a test, but hopefully, again, I was able to answer your important questions. If you have any last minute things, you can try and throw them on Piazza, and I'll see if I can get to them before the test actually begins. But otherwise, yeah, absolutely. I know it is getting dark because I didn't put my light on and the sun went down. No problem, everyone. And again, because I won't see you for another 12 days or so, good luck on the test. Have a great weekend. Have a great reading week. Try and get a little bit of relaxation in too, because we're going to have to go hard when we come back. And otherwise, yeah, best of luck, and go kick some butt on that test. Okay. All right. So I'll see you later in a couple of weeks. Ciao.